Okay, so this is the tutorial on domain and range. Looking at the first one, this is a cubic. There's no restricted domain. All cubics will start down here and finish up here. I don't even need to know how many x-intercepts or what the form is like, because the domain will be all real numbers and the range will also be all real numbers. In g of x, it's a straight line, but it has a restricted domain. So the domain is the restricted domain. The range, however, will be limited to what this restricted domain is. So normally it would go through at 3 and have a negative gradient 1 and look like this. However, it only goes from negative 2, and that is a coloured in endpoint, through to 3, and that's an open endpoint. So 3 minus 3 is 0, so it's actually up here, 3 and 0. And when I put in negative 2 is 3 minus 2 is going to be added together 5. So my range goes from 0 as the lowest, and that's not included, up to 5 included. In the third example, we have this nice little parabola, x squared minus 4. However, it is only bigger than negative 1. So I can get rid of this part of the graph. So my domain is the restricted domain of negative 1 to infinity open circle. And my range, I don't really care what the endpoint is, because negative 4 is my lowest. That will be a square bracket up to infinity. Okay, so for the next one, these are our three implied domains. I am not told a restricted domain like I was here, but there is a restricted domain, but I can work it out. This square root, 4 minus x is bigger than or equal to 0, minus x is bigger than or equal to negative 4, x is less than or equal to 4. So that's my domain, negative infinity through to 4 inclusive. And the little graph would tell me I'm across here at 4 and up at 2, and the graph shoots like that, which gives me a range of 2 to infinity. Here I have a truncus. I have an asymptote at 1 and 4. So my domain, implied domain, is all real numbers except for 1. And my range will be 4 non-inclusive, because that's an asymptote, up to infinity. And then looking at my logarithm, inside here has got to be bigger than 0. So 3 minus 5x is bigger than 0. Minus 5x is bigger than negative 3. X is less than 3/5. So I'm going to have an asymptote at x equals 3/5, and it's going to shoot to the left because of the reflection, which means my domain is negative infinity up to 3/5 non-inclusive, and my range is all real numbers. So I've got a graph here where my domain certainly goes from negative 3 inclusive all the way across to 2 not inclusive, and my range is a lower hot point of negative 2, so the y value of negative 2, and that's inclusive, all the way up to 4, and that's inclusive. Don't care about this endpoint because it's a higher range value of 4. So the domain of G is from negative B across to C, inclusive, inclusive. The domain of H is minus A, not inclusive, all the way to infinity. And the domain of G of x times H of x will equal the domain of G intersect the domain of H. So on a number line, I've got H, which goes from negative B all the way through to C, and I've got G that goes from negative A with an open circle all the way to infinity, and this is the area where they both exist, so therefore we're looking for minus A through to C inclusive on the C. And if we're looking for the domain of the addition, that's also going to be the domain of F intersect the domain of G. So that's going to be on a number line from 0 to 2, coloured in, open circle is my F, negative 5 through to 1, and open circle on the negative 5 overlaps between 0 and 1. Therefore, the domain of that will be from 0 to 1. And that's how we do those domain and range questions.